Components of electrical circuit. We covered Ohm's law, power law, resistances in parallel and series, wiring, how to use a multimeter. Hopefully by this week everybody is a little bit proficient. You feel a little less overwhelmed with using the multimeter. And we'll move on to symbols and components of circuit. So what is a circuit composed of? Three things. Somebody. Source, power source.
Load.
Huh?
Load.
Load
Wire.
and wires, which is a circuit. Think of Ohm's law. You get a power source, which is a voltage. You get amperage, which is gonna go through what? Wires. And we get relays, resistance, which is loads. Guys, can you please try to come on time? It's distracting to the lecture when you come in, please. Okay. So we will talk about electrical loads. What is their purpose? What do they do? How are they connected? Examples of the common loads we use in HVAC. Can you give me one of the most common loads for HVAC?
Motor. Compressor.
And also compressor, right? That's why when you turn the compressor on, the power gets sucked in. What turns the inducer fan? A motor. Motor is the most important load and the most consuming load in HVAC. Second load, what would you think is that?
Fan?
Electrical heaters. They consume a lot of power. So that's loads. I will talk about their purpose, what do they do. Examples of loads that you will see. Samples of the common loads in the field. Explain the symbols and the purpose of relays and contactors. And what is the difference between a relay and a contactor?
The size.
Size of what?
It.
No. What's
Well,
not the size?
Size of the load.
Close? No.
Come on, Bill told us it's like one's for like
Size
110,
of the
one's for
load.
220.
No.
Huh?
Or is it the current?
The current that
Thank
goes
you.
through it.
The amount, yeah.
If it's more than 15 amps, it's or 20 amps, 20 or 15 amps, it's a contactor. If it's less, it's a relay. So it's basically just terminology, and you see a smaller one and you see big ones. But at the end, they all do the same job. It's just a name. There are three names: relays, contactors, and magnetic starter. They're all the same machine or equipment. It's just different size and different names. So they get caught up in the terminology as much as the function. Switches. What kind of switches do we have? What does the switch do? Open and close the circuit. So what kind of things we want the circuit to open and close at? Temperature? What's a temperature switch called?
A what?
A temperature switch. What is it called? Thermostat. Thank you. You just passed this class. Thermostat. That's a thermal switch. You can call it thermal switch. You can call it whatever you want. It is a thermostat. It's a thermal switch. It opens and closes based on temperature. Those are switches. What about pressure switch?
Yep.
Open and close at high pressure and low pressure. Timer. Is timer a switch?
Yeah.
Yeah. Timer is a switch. And there are so many switches and so many sensors. We'll spend the whole course next semester talking about sensors and their purpose and how does it help us control the system without doing a lot of handwork. You go in your car, there's a lot of switches, and they keep adding more switches. The problem with switches is what?
They tend to wear out.
They break, and you end up fixing it. So, and it's a lot of money.
Are they expensive?
Some of them are. Go check out your process switch in the car.
Oh,
That's very expensive. Okay, sensors. There are other miscellaneous control, we'll talk about them, and identify the different type of wiring diagrams used in the industry and each purpose. So you will need to read schematics. Again, they look like hieroglyphic to you in the beginning, but once you take out the panel,
The pictorial ones?
pictorial ones, the ladder one, schematic diagram, they put too much information there. That makes it really hard to read. But the more you focus and know where to start, you can navigate your way through it. Did anybody ever look at a map, a paper map?
Oh, yeah.
Oh yeah, I used to collect.
Do people do that anymore? Yeah.
It's
So what is the first thing you do when you look at the map?
Look at where you are.
Look where you are, and also where's the
The
map
legend.
pointing.
Yeah, what's the destination?
Okay, where you going, where you are in the map, and also you have to put it
I used to
the right
always-
way.
I used-
What does it usually point out to? North.
Yeah.
So you put it north, find you
I
where
used
you are.
to always look at the legend so I know like the.
Legend is a good idea. Every schematic has a legend in it.
A legend?
Yeah, legend is like where you have the
Oh,
names
okay.
or acronyms.
Key.
Okay. Loads. So loads are electrical devices that consume electricity to do useful work. Sometimes useful, we want to be useful. Either a light indicator, it heats, it moves, it opens, it closes. Motors, solenoids, resistance heaters, these are loads, and other power consuming devices. Capacitors, anything that consume energy is load. Is the wire itself a load? It could be, if it's long enough. Usually we don't consider it a load, but if it's very long, it's going to have voltage drop, so it's going to be a load. So you have to think about that. Most important part of heating and cooling your refrigeration system is loads, and they perform all the work. So when you do your project, and you take apart that coffee maker, tell me what is the load? We have switches, that's the button. What is the load? The heater, that's the main thing. A heater and a timer. That's your coffee maker. What is the load in your blender?
What?
The motor.
Yeah.
What is the load in your hair dryer?
Heater?
Fan, and what else?
Here.
And the coil, right? This is your load. What is your switch? It's your finger.
Okay.
So there's always a load, there's always a switch, and there's always a source of power. Any question? Load, source, and connections. Okay. So these are some examples of loads that you might see. Again, the biggest load is a motor. They consume a lot of power. This is an electrical coil heater. You can put this in your furnace. It will heat the air going through it. And this is the same thing you will see in your hair dryer, just a little bit smaller. It's a bunch of coiled wires that will heat up once you run current through them. What about a fan? The load is also the motor. What about this? What is this?
Is it a pump?
It's a pump. The pump is a load. What is connected to the pump? A motor. This is the pump part. This is the motor. The pump hardly ever go bad, but it does go bad sometimes. Mostly we are concerned with the motor. What about this? What does it look like?
Compressor.
Compressor. What's inside the compressor?
Stuff.
Motor.
Motor. It does compress the gas using a motor. And you will find out that we found many ways to use motors. Sideways, rotary, reciprocal, we use motor on everything. So motors are used plenty in the field. What about this one? We looked at it last class.
Coil?
It's a coil, right?
Yeah.
Solenoid coil. What did we say solenoid do?
Oh.
You get magnetized, and boom, it pulls a pin, opening a valve, closing a valve, opening a switch, closing a switch, and you can hear it. If you turn on your car in the morning, once you turn it into on switch without turning the ignition, you hear things clicking, right?
Mhm.
The gas pump is turning on, the car starts like, if all the switches get engaged, you can hear it clicking actually as you go. Try it next time you turn on your car, go into the on position, and do not turn on the car, you hear all the equipment getting ready. Solenoid are opening.
Mhm.
And the last thing is what? That when you turn on the ignition, what happens? Why are you turning? You turn a very strong motor with high torque. Small motor, they're called what?
Starter motor.
Starter motor. Is that what they're using? I think it's starter motor.
I think so.
It's very small, it's under the motor. What does it do?
Starts turning stuff.
It has small gear that connects to the motor and gives the motor a spin. What did we do before the starter motor?
And the hand crank it.
Yeah, you hand crank it.
Yeah.
What about the lawnmower? Sometimes you have to pull. That's what you're doing with the starter motor, just like giving it the head
Then a
start.
motorcycle
Dance with
just
Yeah.
go down.
So they still do that too. If you want to get away with the starter, they have them with airplanes actually. You still have to do that. Somebody goes and push the blade,
Oh, yeah.
and somebody in the cockpit trying to turn it on. So it's still
But
the
what
same
if they
idea.
push it and they get sucked in? Is Isn't that dangerous?
No, they don't have to do it. There's a procedure to it. So again, start to get some kind of awareness of what kind of loads around you, how do they function, what actually happening, and that is actually going to make you a really good technician. When you listen, when you notice, when you try to think, how does this thing work? The more you know how it will work, the more you can guess what went wrong with it. Okay? If you go again, I'm going to use the car example because we all have cars. You go in the morning, you turn the switch on, and you try to engage the starter motor, nothing happens. What is the indication? What's wrong with the car? There is no power. That is completely dead. What if there's light but does not ignite?
Not enough power.
The starter is shot. Could be not enough power to turn on the starter motor, but there's power coming to turn on the small little lights. So start like systematically thinking, what is the problem? What could be the problem? So motors, they use magnetism and electricity to turn things around. We saw that in the video, how we can combine copper and iron to make things work using magnets. So we're making two opposite magnets at the same time so we can move and push that rotor round and round. It's the largest and most important loads in heating, cooling, and refrigeration systems. How do we run the motor? Based on what? Just think about it. If I'm going to buy a motor, what do you think the motor has to do? It's rotate. So
Just to do work.
So what does it have to do?
yeah, if I want to buy a motor, what do I have to match?
Maybe the flow or
RPMs, power.
So all that, and also the RPM, because that's what we need to do. What is the RPM? How fast it go? And there's something else called the torque. What is torque?
Work.
Help power the motor.
Anybody drives a truck?
Torque is work.
Force that the motor exerts.
Yeah.
Is
So what is the difference between torque and horsepower?
Is it horsepower like the amount of, is it like over time, horsepower?
Yeah, horsepower is over time, and it has to do with the speed. You're right. Torque is the twisting force.
Right.
How much you can twist and resist the grinding of the tires. For example,
muscle
one
cars.
second. So for example, if you can buy a Corvette and you have F-150, they're both going uphill. Which one do you think will go faster? Huh? No, the F-150 has a lot of torque, with all the load it can go.
That was
The
bad.
Corvette is gonna be stuck a little bit, it needs a flat road, it's not designed for like very uphill.
Right.
So that's why when you buy a truck, people usually focus on the torque.
That was a bad comparison.
Really?
That was bad, I'm sorry. Because they're gonna be relatively the same power, if not the Corvette has more and it's lighter than the truck.
But doesn't have enough torque. If you
Yeah,
have the
it
same
does.
load,
Yeah, if you get up the hill.
If it has a big block or even a small block, it's very torquey engines.
Exactly.
Corvette?
Yeah,
Maybe I don't know Corvettes, I'm
No,
sorry.
no.
Okay, we take two cars the same horsepower. Bad comparison. Guys, give me a car.
Okay, let's say you have a Passat with a
Same
5-cylinder
horsepower,
gas
different torque.
engine and a Passat with a diesel engine. That diesel engine is gonna beat it up the hill.
Yeah. Why? Torque.
Torque.
These engines give you more torque. So when you buy cars again, there's torque. Apparently, I don't know much about cars. I thought the Corvette is not that. It has a lot of torque. Are you sure?
American V8 engines usually have around the same amount of torque as horsepower.
That's interesting.
The-
So it has 450.
You can buy a Corvette right now with 465 pound-feet of torque.
That's a lot.
That's more torque than its horsepower, right? Because it's like 450.
I digress. Let's talk about F-150 and a Corolla.
There you go.
The point being is, trucks has more torque. The big truck, the 8-wheelers, is 16-wheelers.
18.
Usually they are 18. There's no 16.
No, it's 18.
I'm being fun. Okay. 18-wheelers. Listen, it doesn't have a lot of horsepower,
No.
but it has a lot of torque. As he said, it doesn't have a lot. It has a lot of torque, and it also has a diesel engine because it can get all the compression happening. So when we talk about motors, we want to talk about torque and talk about horsepower. Some motors can go really fast, but it can be stopped by the smallest thing available. So you have a lot of RPM, but you don't have a lot of torque. So you gotta think of the torque, which is different than the horsepower. So we give you horsepower, they give you RPM, and the amplitude goes through it. Okay, so these are some of the symbols you'll see for motors. It can be anything. You don't have to memorize that. It's just they all usually come with a legend. Who said who read the legend? Lewis. So when you see a symbol, go look at the legend. What do they mean by that? If there is nothing next to it, but usually they should tell you. A motor has two windings usually. What do you think those windings represent?
Start and run.
Starter, no, the starter and the rotator,
Oh.
rotor and the starter. So it means that there's two winding, we're having two magnets, it kind of symbolizes the motor. And these are some symbols for different motors, and they, if you can see, they all have the same symbol because they have motors in them. The condenser fan motor, evaporator fan motor, and compressor motor. We're gonna talk a lot about motors. And again, when you go and replace a motor, you can find a replacement for $30, or you can find a replacement for like $200. They require a lot of work to install, especially those ones that they go with the inducer fan motor inside the duct. That requires a lot of work to get it out. So if you get it out and get into a lot of labor work, you don't want to put a crappy one, because in 2 months it's gonna break and you're gonna lose a lot of money in the labor. Same thing with your car. You can buy, in some parts, you want to buy the original, even though it's 4 times the price, because the amount of labor, the labor costs you more sometimes more than the part. How many hours you're going to put into the replacing of the solenoid. So we talk about motors, solenoids. What are solenoids? Again, a coil has a pin. A solenoid can open or close a switch. It can open or close a valve. If you do zoning, we'll talk about that plenty. Zoning. You have hot water running through the house. One zone has its own thermostat. You want to turn on that zone. You want the water to run through that zone. What are you gonna do? You need a solenoid valve. Solenoid valve will open and close. You can have it from here. There we go. No. So that's a solenoid valve. So what does it do? Water goes through it, you energize it, it will either open or close. So I can use a solenoid. If you look, it has a coil in it. It pulls out a pin, opens the flow. If it's de-energized, it goes down. And if you can see the wires here, what do they look like? They look like thermostat wire, right? So that's a solenoid valve. I'm gonna pass it through. Solenoid valves again come in different shapes and prices. Do not skip on instrument. As we said, the more instruments we have, the more troubleshooting we will do, and we want something that has a lot of reliability. They might look the same, they might do the same function, but reliability is another issue. We want something that will work for a long time and has been tested and guaranteed to work for a certain amount of time. What is the life expectancy in a motor usually? A compressor? What are they giving the warranty on a compressor?
Work for it.
Huh?
To work for it.
No, sometimes they do. No, usually for a compressor is 10 years. Because it's the most expensive part of the AC. They last actually more than that. Sometimes that's 20 years, 30 years, no complaint. But they will guarantee you that this thing will work for 10 years. If it doesn't, you can send it back. Compressors are expensive. How much the compressor for your car? The AC. If you notice, the manufacturer one is around like 800, 700, that's a lot of money. Or you can get aftermarket one for around 50. But then you have to charge it, it's gonna leak, it's not gonna last for as long. So that guarantee makes a big difference in the price. And again, think of the labor and also wasting material. So solenoids, again, the mechanism is very intricate. They test it, and they want you to have something that's reliable, that will open and close, and also it depends on the function. So what is the aftermath if this thing breaks? Nothing.
Heat.
You just don't get heat. But if you go into like a power plant, and the solenoid is supposed to open and close a gas valve, that is big. So you have to have something that is reliable, and also you have to have some kind of fallback plan. Yeah, backup for the reliability. This is solenoid valve, and this is some of the common symbols of solenoid valve. What do you think this represents? the coil, and again, it's not always the same, it could change.
That looks like a
Like that.
resistor.
Heaters. What do heaters do?
Heat
Heat. And how does it do that?
by sending electricity to a resistor.
Yes. So we say a wire, when we run current through it, what happens? Two things happen.
Helps power the load.
Now what happens to the wire itself? When you run
Oh,
current, it heats it, and what else? It produces a magnet. So the heat is not that significant. However, some materials have very high resistance, and they heat up faster and produce a lot of heat, and at the same time they do not burn. Usually, they're made out of tungsten carbide, tungsten carbide metal. If you look at the stove, if you have a stove heater, it has those little coils.
No.
If you cut one of them out, you'll see a small little coil inside, going back and forth, and that actually what causes the heat. Do they wear out by time? Yeah. If you buy a coffee maker, in 5 years, it's not gonna work as fast. The heat, actually the property of the material changes over time. So those are heaters. So far, they convert energy to heat. You will see some heaters in ice making machine. So probably, Marcus, you're gonna look at that. When you make ice, you're gonna find some heaters.
Oh, yeah.
So there gotta be some heaters. Coffee maker will have heaters. Question?
So you're saying that these, you said those appliances will change over time, like the material will change over time because of the heat?
Possible, yeah. Depending on the design. Everything changes with time. But over time, they'll tell you how long it will change. They also have a curve of what is life expectancy. So it will perform as expected for a while, then start to decline, and eventually it will go back. So when you have a compressor that's supposed to work forever, it's working forever, but is it the same efficiency? No. Your old car was not the same efficiency as it was when you first bought it. That's why you always go and get a tune-up to try to restore it to the original state. So electric resistance can be used to heat homes, but it's not recommended because it consumes a lot of energy. It could be used to heat a small object or an area as a space heater, or if you want to defrost a freezer. Okay, I'll stop here and